In this video, we are asked to multiply two 8-bit numbers 02H and 04H, which are loaded into registers B and C and store the product in memory location 2000H. Okay, so how do we proceed with this problem? Remember that we don't have any instructions like mul here. So what we need to do is we need to perform repeated addition. Suppose, say, if we have to do 4 into 2, this is 8, and then it could be interpreted as 4 plus 4, adding 4 2 times, which is also 8, and then adding 2 4 times, which is also 8. So we have to choose these repeated addition approach to do this multiplication task. So which of these operations would we do? Okay, for simplicity, we're going to choose this particular part here, repeatedly adding 4 2 times. Now to do this, we first write our pseudocode. So we have two different values, 02H and 04H, loaded into registers B and C. So in the first part, we load 02H in B, load 04H in C. Now what I'm going to do is I'm going to move, I'm not going to move anything. Let me set B as my counter, or okay, we'll do this for convenience. Let me set, okay, yeah, B as my counter because we have to add 2 times, and then C as a part where we repeatedly add this particular number here. So we'll also set an initial sum in accumulator, which will be 00H. So now what we're going to do is we're going to first add A plus C. So 00 plus 04 would give me 04, and then the result would be stored in accumulator itself. Now we are going to decrease the value of B. So B will be 01 from 02, and then we will check if this particular B value has reached 0 or not. So if the B value has not reached 0, okay, compare. If B is non-zero, then we go to this statement here. So we go to step, or else if the value of B is 0, meaning the repeated addition is complete, we have our sum in the accumulator, right? We're going to store this sum, store sum in 2000H, and then terminate the program. So this is going to be our pseudocode. Now based on this pseudocode, let's write down our code. First of all, like I said, we load 02H in B, which can be done using MBI B, 02H. We also load 04H in C. So MBI C, 04H. Now B will be set as counter. We don't need to write any code for this. We just need to keep this in mind, and then C will be used as a value that will be added repeatedly. Let's also load a value 00H in our accumulator, which will be a position for sum. Now we basically need to add A plus C, right? So we perform add C. Immediately after adding, we decrease our counter value, so DCR B. Now when we decrease our counter value, even though the updated value stays in register B, but the flag registers are updated. So we'll check if B has reached 0 value or not. If B has not reached 0 value, we will call jump on non-zero, and then we'll go to some memory location. So what that memory location is going to be is, I would like to repeatedly add C or 04 to the sum until and unless the counter B goes down to 0. Once the counter B goes down to 0, this particular statement is not executed. Now the sum is in the accumulator, so we store this particular sum from the accumulator in memory location 2000H, and then terminate this program. So how would this work? So we'll see here. So we have B as 02H, C as 04H. So during the first iteration, A as 00H. Now during the first iteration, what happens here is we add A plus C. So A plus C is going to be 04H. We decrease the counter of B. B is going to be 01H. Now we check the value of B is if it is 0 or non-zero. Since this particular value is non-zero, now based on the statement that we've written, we move to this particular line again, basically loop to this particular part again. Now in the second loop, we see that we again add C, which means accumulator A is going to be A plus C. We already have 04 in our accumulator, so 04 plus 04 is going to be 08H. Then we again decrease the value of B, which is 00H. Now since the value of B is 0, so this particular statement is not executed. From here the program moves down to here. Now since the result is in the accumulator, we store this particular result in memory location 2000H. So this is how we can perform multiplication in 8085 using the repeated addition approach.